Okay, we're on our last section of math problems, disinfection. These are a little trickier, but are very easily done. All right, the algebraic formula to figure out disinfection is your chemical in pounds equals your dose in milligrams per liter times your flow in million pounds. I'm going to go ahead and draw a pie chart for this one. I want to point out an important point here. Pounds goes up top of chemical. That's what we're looking for. In your pie chart, your flow in MGD goes in the bottom left. 8.34 is a given known, a given variable, goes in the middle chart. And your dose goes in your bottom left. Now here's what I want to point out. I've got my chemical in pounds and I've got my chemical in pounds. I've got my dose in milligrams per liter and I have my dose in milligrams per liter. I have my flow in million pounds. I have my flow in million gallons per day. The one thing that you do not see in the algebraic formula is this given factor of 8.34. 8.34 is the same thing as your flow times 8.34. A lot of people make a mistake with this formula because they forget to factor in the 8.34. This is why the pie chart is so helpful, because you cannot forget to use the 8.34. So let's plug in our numbers for problem number 1. It says the current plant flow is 1.25 mgd and the chlorine gas feed rate is 20 pounds per day. What is my dose in milligrams per liter? Alright, let's plug in our numbers. First variable is 1.25 mgd. We plug in 1.25. My second variable is 20 pounds per day. It goes up top. Question asks me, what is my dose in milligrams per liter? That's what we're looking for. Next step, carry my 20 out. Step number 2, I'm going to multiply these two numbers together. 1.25 times 8.34. That should give me, again, 20 over 10.425. Which should give me a dose of 1.92. Disinfection problems are not that difficult to figure out, or dosage problems are not that difficult to figure out. Go ahead and work the next two. Be mindful on the third problem. It's asking for how many pounds of HTH. Now we know HTH is 65% chlorine. It's not as strong as chlorine gas. So in order to receive the same chlorine dosage rate, or the same residual, you're going to have to actually have more HTH than you do chlorine gas. In order to do that upon this problem, you're going to need to figure out what your pounds is in chlorine gas and divide that answer by 0.65 to get your pounds of HTH. I say 0.65 because most common HTH is 65%. That's why you divide the chlorine gas by 0.65 to find out exactly how much HTH you're going to have to get the same chlorine residual that you do with chlorine gas. Good luck with the math problems. We'll see you next time.